The problem that we're given in example 1 will serve as our template for the first approach that we want to try anytime we're looking at solving an exponential expression. What we have on the left hand side is 8 to the x power, and on the right hand side 8 to the 5th power. Since those bases are the same on both sides, the only thing that's different is what we have in the exponent, meaning if x and 5 are equal to each other, then these two expressions are equal. So in this case, that simply gives us our solution. X equals 5 would make this statement true. Whenever we are given an exponential equation, then what we want to do is first look at trying to rewrite one or both sides of the equation so that we have exponential statements with the same base. In example 2, we have 2 to the negative x power is equal to 16. We can rewrite 16 as 2 to the 4th power, and now solving this is almost as simple as solving example 1. Once the bases are the same, we can set the exponents equal to each other, and in this case we would get negative x is equal to 4 or x is equal to negative 4. In example 3, we want to try the same thing. We have 3 over 2 raised to the x power. On the right hand side we have 27 and 8. If we were to rewrite that as 3 halves to the 3rd power, then 3 to the 3rd power would be 27, 8 to the 3rd power would be 2. So we have the bases the same, and we can just set our exponents equal in order to solve, and in this case get x equals 3. Example 4 will start off with essentially the same approach. We want to rewrite 25 to the x power as an exponential expression base 5. 25 can be rewritten as 5 squared, and that quantity being raised to the x power. We can combine those exponents to rewrite this then as 5 to the 2x power. Now we have the bases the same on each side, so we can rewrite this as x squared minus 99 is equal to 2x, or we can essentially just set those exponents equal to each other. If we subtract 2x to the left-hand side, now we have a quadratic function that we can look at factoring in order to solve. In this case, this would factor as x plus 9 times x minus 11, which would mean x equals negative 9 and x equals positive 11 are both solutions to this exponential function, or exponential equation. In the next two examples, we don't have anything quite that simple. Here we're looking at something with a base e and something with a base 2. Without a lot of pretty difficult work, there's not going to be any easy way to rewrite this. So what we can do instead is apply a logarithm to both sides. I like to apply the natural log, but really we can apply a log base any value we want. So if we apply the natural log to both sides, on the left-hand side, that will allow us to bring that exponent of 8x down as a factor in front, times the natural log of e is equal to the natural log of 2. In this case, the natural log of e just becomes 1. So we're left with 8x is equal to the natural log of 2, or x is equal to the natural log of 2 divided by 8. I like to use the natural log because that's something that we can evaluate with a calculator. So if we wanted to, then we could come up with an approximate result there, which we will be asked to do in example 6. So in example 5, we have this exact result written in terms of that statement, the natural log of 2. In example 6, we're going to want to provide both an exact and an approximate answer. What we can do to start off would be, again, taking the natural log of both sides of this expression, which would allow us to bring those, bring those powers down as a factor in front. So we would get 1 minus 9x times the natural log of 6 is equal to x times the natural log of 5. What we'll do then is expand on the left-hand side. We'll take natural log of 6 and multiply it through that expression. And next, group all of our x terms on one side of the equation, all of our non-x terms on the other side of the equation. So we'll leave natural log of x where it is, and subtract 9x natural log of 6 to the right-hand side. And then from there, factor out that x that's common on the right-hand side, leaving us with x times the quantity natural log of 5 plus 9 times the natural log of 6. And then we can divide both sides to get x isolated by itself equal to the natural log of 6 over the natural log of 5 plus 9 times the natural log of 6. So in this case, this would be our exact answer. But we could plug that into a calculator, being very careful with parentheses and how we divide. We should be able to get an approximate answer of 0.101.